Hello everyone, welcome to CAC 260 Digital Logic Design tutorial. In this tutorial, we will discuss the conversion between decimal and other bases. For example, if we need to convert a decimal number to base r, then what will we do? We have to divide the whole number by the target base r, and if the number has a fraction part, then we have to multiply it by r. So, if a number has a whole part and fraction part, then the whole part will be repeatedly divided by the target base r, and the fraction part will be repeatedly multiplied by the target base r. 43 is a decimal number. We will convert it in binary, and the base of binary is 2, so we will repeatedly divide 43 by 2. So when we will stop when the quotient part will become 0. So let's start. First 43 is divided by 2. We can see that 21 is the quotient and remainder is 1. Remember, the first remainder will be our LSB bit and the last remainder will be our MSB bit. So first quotient is 21 and remainder is 1. Then we'll divide 21 by 2. We can see the result that if we divide 21 by 2, 10 is the quotient and 1 is the remainder. Then 10 will be divided by 2. We can see that the quotient is 5 and the remainder is 0. Then 5 will be divided by 2. Then in the next step, the quotient will be 2 and the remainder will be 1. Then 2 will be again divided by 2 base 2. So quotient will be 1 and remainder will be 0. Then this 1 will be divided by 2. We can see if we divide 1 by 2, we can see that the quotient will be 0 and remainder will be 1. So as our quotient is 0, we will stop the criteria and we will keep this remainder as our binary digit. So we can see the equivalent binary number. Here you can see I said that the last remainder will be our MSB bit. So here this one 0 and 1 will be here. So here is our answer 101011. Now what about fraction? So if the number has a fraction part, for example this number, it has no whole part, only fraction part, that is 3125. So how will we convert it to a binary number? The target base, that is the base of binary, is 2. So we'll divide it. We'll multiply the fraction part by the target base, that is 2. So let's multiply 0.3125 into 2. We can see the result, that is 0.625. So this 0 will record as our targeted digit. Now the first digit will be our MSB, not the LSB as the whole part, like the whole part. Again 0.625 will be multiplied by 2. We can see the result 1.25. We will record this one, and 0.25 will be multiplied by we again will be multiplied by 2 and we will record this 0, and 0.5 will be multiplied by 2. We can see the result, that is 1.00, and this one, the last uh, the result of the last multiplication will be our LSB bit, and we'll stop this criteria because the fraction part of the result becomes 0. So when the fraction part of the result will become 0, we'll stop this criteria. So here is our equivalent number, that is 0.0101. Here it is MSB and it is LSB. So what is the difference between the whole part and the fraction part? In whole part, division by base of the target, and in fraction part, it will be multiplied by the target base. Uh, in whole part, we'll collect the remainders, and in fraction part, the whole part of the result will be recorded. And in whole part, by division, we'll obtain LSB to MSB, and in fraction part, we obtain MSB to LSB. So now let's discuss conversion between bases. In general, conversion between bases can be done by decimal. For example, if you need to convert a base r to base 3, first we'll convert base r into decimal, then we'll convert decimal into base 3. Now here is a shortcut formula how we can convert binary to octal or binary to hexadecimal, or octal to binary or hexadecimal to binary directly. Remember, this rule is only for these three number system, that is binary, octal and hexadecimal. It will not be actually applicable for any other number system. So what should we do if we convert a binary to octal? First, partition the binary number into groups of 3. See, you can see that here is the binary number. So we'll partition this into group of 3. So let's start just before the fraction point. We'll group it. Here is another group. Here is another group, and here is another group. You can see that this group has only 2 members, that is 1 0, but it is not a problem. We can always add a 0, because by adding a 0 on the leftmost side, uh, the value will not change. Now we'll convert this group into a octal number. For example, 001, it will be 1 in octal, and 001 it will be 3 in octal, and 111 it will be 7 in octal, and 010 it will be 2. Now let's partition the fraction part. We can see that it has 6 members, so we can easily group it into 3. So 101 will be 5 and 110 will be 6. So here is our equivalent number. Now what should we do when we need to convert a octal number to a binary? Well, that's easy. Each octal digit will contribute to at least 3 binary digits. For example, 2. 2 will be converted to 010. You can add 010, it will there will be no problem. And 7 will be converted to 111. 3 will be converted to 011. 1 will be converted to 001. 5 will be converted to 101, and 6 will be converted to 110. Now comes to binary to hexa. Now we will partition the number into groups of 4. For example, we can see we will start just before the fraction point. It is a group, and it will here is another group 1101, and you can see that it has a group, but it has only 3 members. But no problem, we can add 0 because the value will not change. Now let's convert it. 1001 will convert it into 9, 1101 will be converted into D, and 0101 will be converted into 5. What about 1011 and 1000? 1000 will be converted to 8 and 1011 will be converted to B. Actually 1011 it is 11, and in hexa 11 will be represented by B. Now comes to this conversion hexadecimal to binary. Um, we have now each digit in the hexa will contribute to 4 binary number. For example, 9 will be converted to 1001 in binary. D will be converted to 1101. 5 will be converted to uh, 0101, and B will convert it to 1011. 8 will be converted to 1000. It's a shortcut, so you don't need to use the shortcut. You can always convert a binary or octal to a decimal, then convert the decimal into other format. Here is another example. We need to convert this binary into octal or hexadecimal format. So if we need to convert it into a octal format, then we'll partition this in group of 3. So let's partition. First partition is 100, that is 4. Second partition is also 100, that is 4. Now we can see that it has only one member, but there will be no problem. We can add 20, so it will be 1. So we can see the number 144, and we can see that now comes to the fraction part. It has only 2 members, but we can add always 0, because if we add 0 after the fraction point, this value will not change. So this one will be 4. So you can see the conversion 144.4. Now what will be its hexa format? We can see that we have to partition this into group of 4. So you can see 0 1 0 0, it is 4. Now this one 0 1 1 0, this will be 6, and this one 1 0 0 0, so this one will be 8. So in this way we can directly convert binary to octal, or binary to hexadecimal, or octal to binary, or hexadecimal to binary. Thanks everyone for watching this tutorial.